Simplifying, multiplying, and dividing fractions. These are the solutions to the worksheets, solutions to the odds. We're going to simplify the fraction 3 over 9, and in doing so, we're going to use factor trees. I need two numbers multiplied together, which is 9. The answer is 3 and 3. Now that's good because they're both prime. What this means is 9 can be written as the product of its primes. We want to break our numbers down into primes. The numerator of our fraction, the number that's on top, this numerator, is 3. It's already prime. The number on the bottom, however, is not. We can break it down. 3 over 3 times 3. We're going to use our cancellation property, meaning if I have something on top multiplied to another thing, and I'm going to divide by that triangle over my happy face. The cancellation, or the simplification property, is simply stating that I can cancel what's on top and what's on bottom. What I'm left with is simply the square over the happy face. This is the property that we'll be using. So this 3 and this 3 goes away. I'm left with a 3. However, I have to notate that I'm left with a 3 on the bottom. It's a denominator value. And notice that nothing is left on top, but any number times 1 is itself. So I'm going to put the 1 here so I could describe my final answer as 1/3. 3/9 is really 1/3. Number 3. I have to simplify 48 over 54. Both of these numbers are not prime. I'm going to have to break them both down by using factor trees. 6 times 8 is 48. 3 times 2 is 6. 2 times 4 is 8. And 2 times 2 is 4. I'm going to circle all of the primes because 48 can be written now as, we'll put it down here, 3 times 2 times 2 times 2 times another 2. It's simply written as a product of these primes. We're going to have to do the same for 54. 2 times 27 is 54. 3 times 9 is 27. 3 times 3 is 9. 54 is written as 2 times 3 times 3 times 3. 2 times 3 times 3 times 3. The product of its primes. I'm now going to replace 48 with 3 times 2 times 2 times 2 times another 2, and 54 with 2 times each one of these 3's. I'm going to cancel. Notice there's nothing left to cancel. I can only get rid of that 3 that's on top and on bottom, the 2 that's on top and on bottom. There are no other numbers on top and bottom. These are the numbers that are left. When I multiply I end up with the value 8 over 9. I have simplified. Number 5. 33 divided by 360. Both of these numbers are not prime. I'm going to have to break them down. 33 is written as 3 times 11, 2 primes. 360 is a bigger number. 10 times 36 is 360. Both of these numbers are not prime. Break down my 10. 2 times 5 is 10. They're both prime. 6 times 6 is 36. Both of these numbers are not prime, but they both can be broken down or written as 2 times 3. If I take a look, 33 is 3 times 11. 360 is 2 times 5 times 2 times 3 times 2 times another 3. I write these as primes. So my 33 is 3 times 11. 360 is 2 times 5 times 2 times 3 times 2 times another 3. The only thing that cancels is a single 3. It doesn't matter which 3 we cancel. 11 is left on top. All these other primes are left on top. We're now going to have to multiply. 11 is on top, but 2 times 5 is 10, times 2 is 20, times that 2 times 3, which is 6, we get 120. I have simplified 33 over 360. It is 11 over 120. This is guaranteed to be simplified because the prime 11 and all these other primes down here do not cancel. Number 7. 198 divided by 18. We are going to simplify this fraction. It's improper, but that's not a problem. We're going to break down 198. It's written as 2 times. We're going to have to do some division. Let's see. 2 goes into 198. 9 times 2 is 18. Subtract, you have 1. Bring down the 8. 2 goes into 18 9 times. 9 times 2 is 18. We get a 0 remainder. So 2 times 99 is 198. 2 is prime. 11 times 9 is 99. 11's prime, and then 3 times 3 is 9. We broke down the number 198 into its primes. 198 is 2 times 11 times 3 times 3. We now have to break down 18. 18 is 2 times 9. We can write 6 times 3, but it doesn't matter. 2's prime. 9 can be written as 3 times 3. So that 18 is the product of 2 times 3 times 3. Let's see what we can simplify. 2 times 11 times 3 times 3 is 198. 2 times 3 times 3 is 18. 2 cancels, 3 cancels, another 3 cancels. We're left with 11 on top. Your final answer is going to be 11 over 1, which is really the number 11. We could have, but we didn't know, simply divide 198 with 18 to get 11. Number 9. We are multiplying fractions. You multiply fractions by multiplying the corresponding numerators together with the corresponding denominators together. In other words, multiply horizontally across. We get 5 times 5 over 8 times 8. Notice if we're to break down the 8 into its primes, you would get 2 times 2 times 2 for the first 8, 2 times 2 times 2 for the second 8. The point being, the top has 5s. There's 2 5s there. The bottom is just a string of twos. Nothing cancels. In other words, I can't get rid of a 5 that's on top with a 2. This means our answer is simplified. We just have to multiply. 5 times 5 is 25, and 8 times 8 is 64. We're done. This fraction is simplified. Number 11. 11 over 30 times 19 over 23. We are multiplying fractions, and we multiply horizontally across. So I get 11 times 19 divided by 30 times 23. Notice 11 is prime, 19 is prime, and so is 23. Number 30 is not prime, but we can write it as the following. 30 can be described as 2 times 3 times 5. If we write 30 as a product of its primes, these are all the prime numbers. 2 times 3 times 5 we replace with 30. And let's look at these primes and notice that nothing cancels. The 11 on top does not cancel with any of the primes on the bottom. The 19 on top in the numerator does not divide with any of the numbers on the bottom as well. This means we're done. All we had to do is multiply 11 with 19 to get an answer that's in the numerator position, and 30 times 23 to get the denominator. We are multiplying fractions. However, we're going to have to use our multiplication algorithm. 11 times 19. 9 times 1 is 9. 9 times 1 is 9. 1 times 1 is 1. 1 times 1 is none. Add. The numerator is 209. To find the denominator, this is 30 times 23. 3 times 0 is 0. 3 times 3 is 9. 2 times 0 is 0. 2 times 3 is 6. 0, 9, 6. 690. This is my answer. This fraction is a reduced fraction. Breaking this down was all the work to the left. Number 13. 5/3 times 5/2. We multiply fractions by multiplying horizontally across. What we end up with is 5 times 5 divided by 3 times 2. If we take a closer look at these numbers, 5 is prime, the second 5 is also prime, 3 and 2 are primes. We cannot cancel. We don't find the same prime on top and bottom. So that means we're done. That if we multiply, we get 25/6. This fraction is reduced or simplified. 15. 4/a. Let's make this an a. Times b/7. We are going to multiply. This is the operation. When we multiply, we get 4 times b/a times 7. If I take a closer look, the 4 can be written as 2 times 2. So when we try to simplify or cancel the primes, let's notice that 4 written as a product of its primes is 2 times 2. B is thought of as a prime that we can't break it down. We don't know the value. A is also thought of as a prime. We can't break it down. We don't know the value. 7 we know is prime. Notice that nothing cancels. That means we don't have the same prime on top and bottom. Final answer is going to be 4b/7a, just to say that we could have written the denominator here as a times 7, but in algebra we typically write this kind of information with the number before the letter. So you should see 4b divided by 7a. Number 17. 8/9 times 19/17. We multiply fractions horizontally across. You get 8 times 19/9 times 17. We're going to break down our numbers into primes. 8 is 2 times 2 times 2. 9 is 3 times 3. If we notice that 19 we can't break down, it's prime. 17 is prime. We broke down the 9 and we broke down the 8. None of these primes cancel. So all I have to do is perform the multiplication, and I am done, and I am guaranteed that my answers are simplified. Let's do the arithmetic. 8 times 9 is 72. 8 times 1 is 8 plus 7 is 15. 17 times 9. 3, 6, 9, 15. Your final answer is going to be 152/153. This fraction is simplified. Number 19. 1/3 divided by 1/6. When we divide fractions, we keep the first one the same and we flip the second one over. This is a reciprocal. That means the second fraction here is flipped over and written as 6 over 1. This is what we do when we divide. We are now multiplying the first fraction on the left with the reciprocal of the second fraction, and we multiply horizontally across. So I get 1 times 6 over 3 times 1. I can multiply 1 and 6 to get 6 over 3. I can break these fractions down, but notice I have 6 divided by 3. This operation is division, so that 6 divided by 3 is the value 2. I am done. (21) 4 divided by 12/5. We are dividing again. We write this as 4 times the reciprocal of 12/5, which is 5/12. Let's take a closer look. We're dividing by a fraction. Keep the first fraction the same. In this case, it's a whole number. And you multiply by the reciprocal of 12/5. It turns out to be 5/12. Now this 4 is really over 1. We are multiplying fractions. We multiply horizontally across. We end up with 4 times 5 over 12. All of our fractions need to be reduced, so we're going to have to break down these numbers. 4 is written as 2 times 2. 5 is already prime. 12 is 2 times 2 times 3. Let's take a closer look at the primes. 2, 2, 5, 2, 2, and 3. I'm going to have 2 times 2 times 5 over 2 times 2 times 3. We get to cancel that first 2 on top and bottom, that first pair, and the second pair. Notice we're left with a 5 and a 3 that we can't cancel. The final answer is 5/3. 23. 70 over 27 divided by 7/3. This is a division question. We have a first fraction on the left, which is 70 divided by 27. We are now going to divide by the second fraction, which is 7/3. This is going to become 70 over 27 times the reciprocal of 7/3, which is 3/7. Notice we multiply that first fraction by the reciprocal of the second fraction. 70 times 3 over 27 times 7. We're going to have to break down these fractions into their primes. I should say, break down these numbers into their primes. 70 is written as 7 times 2 times 5. 27 is written as 3 times 3 times 3. Let's take a closer look at our primes. 7, 2, 5, and 3, 3, 3, 3, and 7. If I write them down, here's what I get. 7 times 2 times 5 times 3 over 3 times 3 times 3 times 7. We now get to cancel. 7 and 7 go away. A 2 does not cancel with any of the numbers on the bottom. The 2 in the numerator, which is on top, does not cancel with any of the 3's. A 5 does not cancel with any of the numbers on the bottom because the numbers on the bottom are 3's. This 3 cancels with any of the 3's that I have on the bottom. Let's see what's left. Our final answer is going to be 2 times 5, which is 10, over 3 times 3, which is 9. We have reduced this fraction. It's 10/9.